Hello guys, welcome back to KD Code. In this video, we are going to learn about a problem statement about two-page sum. This is a very famous problem in DSA. Let's see the problem statement first and then we go ahead and do the solution. Okay guys, so this is the problem statement guys. We are provided with an array and also an integer target. So we need to find the sum of two integers in the array which is equal to the target value given in the input, right? If these two integers are present in the array, then we return true, else we return false. So this is the overall problem statement guys. We need to find two integers where their sum is equal to the target value given, and if these two integers are present in this array, then we will return true, else we will return false. Same way, this is the second example they had given, right? So let's take one example guys. The first one, 1, 4, 45, 6, 10 and 8, right? Let me make it a bit bigger. Okay, and our target value is 16 guys, right? So this is the input array and our target value is 16. Now we have to find two integers in this array where their sum is equal to 16. That is the target value, right? So whenever you think of this problem, what comes to your mind guys? It is very simple, right? We have to find two integers. So we just have to iterate this array twice, right? So we need two integers, right guys? So let's take those two integers as integer 1 equal to and integer 2, right? Okay, now what we have to do, let's take 1 as our first integer, right? If 1 is our first integer, then what could be the integer 2 value? So integer 2 is nothing but 16 minus 1, right? 16 minus 1 is nothing but 15. So integer 2 is 15. So what can we analyze from this guys is, if you take 1, we need to find 15 in the rest of the array. Then only we can find the sum as 16, right? And if we take 4 as the first integer here, then what could be the second integer guys? It is 16 minus 4. This is nothing but 12. So if we take 4 as first integer, we need to find 12 in the rest of the array. And if we take 45 as our first integer, what we have to do? 16 minus 45. It is negative value. So we don't care about negative values guys here, because the given array is a positive values. So there will be no negative values present in our array. So we don't have negative values. So negative value in the array is not possible. So we will not take second integer as negative values guys. So it is not possible. So going forward, we can take 6 here again as our first integer, and 16 minus 6 is nothing but 10. So in the rest of the array, we have to find if 10 is present or not. Yes, it is present here right after 6, right? Then it is our two integers guys, where our sum is equal to our target, right? So we will return true. Whenever we find this pair, we will return true. First, suppose if there is no 6 here, there is 5 here. We'll take 5 here, right? And 16 minus 5, 11, right? So in the rest of the array, we search for 11. But 11 is not present in the array. So we go forward and take 10 as our first integer. And 16 minus 10, it is 6. So 6 is not present in our array, in the rest of the array. So it is not possible for 10 as our first integer, and there is no match for it. And 8, let's take 8 as our first integer. So there are no elements left to search for in the array on the right side. So we didn't find any match for our sum for 16. Then we return false, right? So this is our observation guys. We take one element and we search for the second element in the rest of the array. This is the first greedy approach we will do when this problem comes to our mind, right? So let's try to write some code for this. So I take a for loop and I iterate over the array dot size, right? Then this is the first integer I'm taking, integer 1. I'm writing the algorithm guys. You can modify it based on the programming language you are preferred. So I'm taking one more for loop and I have to search the second integer in the rest of the array, right? So the second integer we have to find from the rest of the array. So rest of the array starts from this I, and rest of the array starts from I plus 1 to the end of the array, right guys? So I will take j as I plus 1. So I will start my searching from I plus 1 to the rest of the array. So now integer 2 is array of j, right? Then what we have to find? We have to add these two integers so we can find the sum as 16. So let's take that. We have to add them. So integer 1 plus integer 2 equal to target. If it is equal to target, then what we'll do? We find the match. We return true, right? So this is a for loop, two for loops. We are iterating over this array. Once we are taking integer 1 and we are finding second integer in the rest of the array. If it is present, we are returning true, right guys? What is the other case? If the match is not there in the array, we do not find the pair, two pair sum for the target value, what we have to return and when we have to return it. Whenever our I comes to the end of this array and we still didn't find any of the pairs, then we have to return false, right? So after this for loop is totally completed, then it comes out of the for loop, right guys? And we are sure that if it comes out of the for loop without going inside this if condition, then we do not have any two pairs inside this array, right? If it is there, then we just return the true and it will not come, the program control will not come outside this for loop, right guys? So if it comes outside the for loop, then we return false because we do not find any two pairs sum. So this is the algorithm, guys, and this algorithm takes time complexity of big O of n square, right, and constant space complexity, which is big O of 1, right? So the algorithm takes time complexity as big O of n square and space complexity as constant. So we are not using extra space here, so it is constant, and we are iterating over array 2 times for each element. So we are iterating approximately n square times. N is nothing but the size of the array, right? So we have to optimize this solution. We don't have to iterate 2 times the array, and we just have to iterate over 1 time through the array by storing the values we visited, right? Let me show you the optimized version for this algorithm where we will use map for this. So why do we use map? So consider this array again. We visited 1 first. We are iterating only once now. We visited 1. What if I stored 1 already as visited? And so somewhere in this array, if I find 15, value 15, that is 16 minus 1, right? 16 minus 1 is 15, right? If I find 15, I can ask values I visited if there is 1 in this map or not, right? If it is present, then I found the match. In the same way, I'll take 4 and 4 I will store it here, right, as visited. And somewhere around in the rest of the array, whenever I am iterating going forward, if I find any 12 value, I can ask my map for 4 value if it is visited before this 12 or not. If it is visited, then I can say 4 is already present in the array and now I encountered 12, so I found a match, so I return true, right? So in the same way, let's consider one more example. I take 45, right, and I make it as visited in this dictionary or map, and going forward I will not find any negative values, right, because 16 minus 45 is a negative value. So even though I store it, I don't find any negative value, so I don't have to store it, right guys? So this is one edge case where we'll try to minimize the storage part here, right? So we'll skip 45 and then we take 6 here. We'll store 6 as visited here in the map, and going forward in the searching process while iterating through this array here, the rest of the 2 elements, we'll find 10, right? For 10, we'll ask the map if 6 is already visited, like 16 minus 10 is 6, right? If 6 is already visited, it is there here, so we find a match, return true. So each and every element I'm visiting here in this array 1, 4, 45, each and every element here I'm visiting, I have to ask the map if that target minus the current value is there in the map or not. If it is there, then we return true. If it is not there, we store this current value in this map, right? So it is very simple, guys. Let's try the algorithm. So I'm taking, for C we take another map, for Python we take dictionary, and whatever the language, the algorithm remains same. So let me take C++, it is unordered map, right? We store integers, comma integer, that is key as integer and value as integer, right? And I take umap, the variable name, and I have to iterate through the array only once, right? So integer I am iterating only once, and I have to find whether the target minus current value is present in the map or not, right? So if target minus current value, what is current value? I is in the map, right? So I have to take umap and insert this as a key value, target minus I. If it is equal to 1, if it is present in the map, then we can return true, right? Return true. If it is not present, what we will do? We will store the value in the dictionary, right? So we will store umap of I equal to 1, like that, right? So this is done. But let me take, there is one edge condition here where we are wasting our storage part to store the value which might not be the solution, right? Because 16 minus 45 is a negative value, and we do not encounter any negative value in the positive integer array, right? So I don't need to store it, the 45 value in here. So what can I do is, I can do this. Else if condition, I will put target minus I is greater than 0, then only I will store it. Else I will not store it, right? Okay guys, so we took care of the edge case, that is the negative value output for the 45 value, right? But the problem is not yet done, guys. We are checking for true value case, but what about false? So how do we handle the false case? The false case is nothing but we iterate through this array and we came across the end of the array, right? Whenever we came to the end of the array, still we did not find any matching elements. So whenever we do not find any matching elements, we come out of this for loop, right? And if there is any matching element, we go inside this if condition and return true, and the control of the program will not come outside this for condition, right? In the same way how we discussed for the solution 1, in the same way we return false outside this for loop, right? Like this. So now it is all done, guys. So this is the optimized version. And let's discuss the time complexity and space complexity now. So the time complexity here is big O of n, right? And in the same way space complexity is big O of n. Why it is big O of n? See, we are storing UMAP here, that is nothing but map, where in the worst case we will store all the elements if there is no matching form, right? So it is big O of n. And time complexity, we are iterating through this array only once. So using one for loop, we are iterating only once. So we are checking each and every element here, which is of size n. So the time complexity is big O of n. I hope it's clear. Let's implement this program in our VS Code, right guys? So this is the program to sum, and I took an ordered map here in the same way how I explained in the drawing board. I have written the code here. So UMAP of target minus I equal to 1, that is the case where we found our second integer in the map for the current integer I, else we will store our current integer in the map. At last we will return the false, right? So these are test cases I have taken, so I just have to run them. You see the output here, true, false, false. So this is the output, guys. True for the first test case, 16 is the target value and this is the array. So for 16, 6 and 10 is the solution and we return true. For second test case, if you observe, 11 is the target value and whatever we do after 6, the logical value is 4. So 6 plus 4 is 10. Maximum possible value is 10. So 11 is not possible here, so it will return false. In the same way the test case also. So this is the two sum pair solution, guys. Please like the video if you understand the solution, and please comment below if you find any easier solution than this. It will be useful for others also. Let's learn together and grow together. Thank you guys. Thanks for watching.